Oh, that's even better. It's a longer wire here. Ryan with Geek here, and in this video, we're back with the DC40-V2 Part 7, the smoke test. We've got a speaker and a battery pack. And this battery pack is probably really close to being dead. I'm going to set it down here. I'll just move this out of the way. Let's set this here, and I'm going to set my multimeter here. Let's do a quick test and see how many volts we don't have. I haven't used this battery pack in a long time, and the batteries are pretty old. So what we're going to do is just plug this on in, turn this to off, then back to DC, and try it again. 9 volts, which is fine. We're not looking for high voltage here. So that's going to work just fine. And so what we're going to do is just try to get this audio amplification circuit tested. So to do that, let's give it the old smoke test. So here we go. Hopefully no magic smoke escapes. And let's see, there's a, that's a whisker of hot glue. Okay, I was making sure it wasn't electrical, metal, conducting. Oh, hear that? That's good-ish, I guess. All right, so we've got something happening. The speaker at least makes noise. And let's see, let's check the transistors and see if they're hot. If they're starting to get really hot, that means they're wired in wrong and I did something wrong, but they're all cool to the touch. The input is right here, so I'm just going to touch this. So we've got input. That's pretty good. Here's the output, touching from the output too. So seem to be getting more from the input than the output. So that's pretty good, I guess. I don't have any strong AM radio stations nearby to bleed through, so don't have any AM bleeding through. So the audio amplification circuit seems to work. The next step is going to be wiring up the VFO input here and the output going to here somewhere. Well, right there actually. And we got to hook up the VFO, got to build a VFO for it, which will be the next. I'm thinking about using ChatGPT and maybe making a video of how to use ChatGPT to program your Arduino for a VFO. So let me know if you'd be interested in seeing that. If not, I'll just do it or just use a sketch I already have or modify a sketch I already have. To start, I did decide that I'm going to go ahead and start with this VFO and a 16:2 or 16:4 display because I already have them all pre-configured, ready to go. Now, I did get a bunch of these guys. This is the Sugar Cube VFO and an SI5351 solders there, and then a pit, or a, what is it called? An AT Tiny 25 8-pin dip solders over it. And then there are a couple of resistors here, which I'm just going to use through-hole resistors rather than surface mount. But you still have to hook up a display. You have to hook up one of these guys. So I'll probably actually use this one. Yeah, so there's still work to do there. It's actually quite a lot of work. I got to build the whole thing, right? So we will see what happens with this. I did get 25 of these little boards, and I bought them over at PCBWay, and I uploaded the Gerber, and it said it was $5. So I just increased the number of these until it went more than $5, and I backed it down, and that was 25. And you figure 25 of these makes up just under 100 by 100 square of PCB. So that's how it worked. And then they did it all, and I didn't have to do any panelization or anything. I just ordered 25 of them, and 25 of them showed up. So anyway, that's it for this video. And those are still nice and cool to the touch, which is good. If you have any comments or questions, please post them below. If you like this, make sure you do the whole subscribe thing. Whoa, that just Yeah. Wow, that was cool. What's that all about? Well, anyway, yeah, do the whole subscribe and like thing and follow along. The next video is going to be hooking this up, or possibly do the VFO, one of the two. Who knows? Maybe we'll do both. All right, see you next time.